channel. Today we're going to talk about selection sort. So the purpose of me doing this is to consolidate my understanding of the sorting algorithms and share with you my way of approaching and understanding the algorithm. So sorting is the action of organizing items in a series in some kind of order. For a sorting algorithm, we're ordering stuff in ascending order, so from low to high. We can sort a lot of stuff in our lives. Maybe we want to, just for fun or for some practical purposes. Maybe you want to sort numbers. I remember doing sorting numbers exercises when I was small, when we learned about numbers. We can also sort characters, sort words in a dictionary, sort plane tickets based on price range. So there are so many things for it to sort. So sorting is actually a very important part in our lives. So to approach this, I always try to think of a keyword or a one-sentence summary of the algorithm. So for selection sort, it's actually in the name. And I think my one-sentence summary would be choose or select the smallest item in the unsorted subarray and put it in its correct position. Now let's demonstrate the idea with an example. So I have an array here of 5 elements, and I have written down in pencil the indices of them. So now let's create an unsorted subarray. We now see that this is the unsorted subarray. And there's nothing that has been sorted. So the sorted subarray would be 0 elements. So first we want to see which is the smallest element from here. So we are now here. Is this smallest? Well, technically right now it is. So we find the smallest element by going through each and every elements in the remaining part and compare it with the minimum. So for our first iteration, 5 is currently our smallest. Is 1 smaller than 5? Yes, so 1 is now the smallest. 9 is bigger, no. 4 is bigger, no. But 0 is smaller. So 0 is the smallest element in the unsorted subarray. So we're now at the first element at our first iteration. So we will swap these with each other. Swap these based on the indexes. So instead of actually retaining information about the smallest element itself, we're storing information about where the smallest element is so that we can swap them with the current element that we're at. Why do we know it is always correct? Because we go through the rest of the unsorted subarray and choose the smallest element in it, so that can't be wrong because we have done so much work. So we know this one is actually sorted. Because it's sorted, I will color it. Okay, maybe just do it quickly. Alright, so we know this is sorted. Now because this is sorted, this is our sorted subarray, and this is the unsorted subarray. So for the next iteration, we continue to find the smallest element. Now let's assume that this is the smallest element. Is it smaller? No. So it's pretty quick for us because we can eyeball it, but imagine if we have like so many, then it will take a lot longer. So we can see this is the smallest one. I'll color it to mark that this is part of the sorted subarray. We continue to do that. Let's assume this is the smallest element. Is it smaller? Yes. So this is the smallest element. Is it smaller than 4? No. So this is our smallest element. We continue to swap. Notice that we always swap our smallest element with the beginning of the unsorted subarray. So 4 is now here. We see we're almost done. So to mark that this is the part of the sorted subarray, I'll color it. 4 it is, and then now we have 3 in sorted part and 2 in unsorted part. So let's consider this is the smallest. Is it smaller? Yes. So this is smaller. So we swap it. And then we would color it. And then because we only have one element left, so it's already in place, in the correct place. We don't have anything to compare it with, so color it. We're done. So that is how selection sort works. Let's write down the code together. As we can see, we now have the code and the analysis. The code demonstrates the idea we have just discussed with our example above. For the analysis, selection sort is traditionally not stable. In place and space complexity are talking about the same thing. That is, we don't really need any auxiliary array to do selection sort. The time complexity would be O(n) squared. So it's quadratic even if the array is already sorted, because we don't really have any way to know if the array is sorted or not. Every time, every iteration, we still need to go through every element in the unsorted subarray to find the smallest element and put it in the correct place. So even if the array we're giving in the beginning is like this, with 0 at the first, we need to find the correct element in this position. So we still have to iterate all over the rest because we don't know what the rest look like. So I think that is selection sort. Thank you for watching and see you next time.